here is the scenario. Let's get straight into it. I'm going to zoom out a little bit so you can see the whole. There we go. So Paul is residing in Kimberley under Salt Lake municipality. He is planning to build himself a swimming pool. Now, being someone from Durban, I love the idea of a swimming pool. But is there anyone from the Free State, Northern Cape, Northwest Province, any of those provinces that are thinking about building swimming pools? What in the winter, doesn't that pool freeze over? I'm only asking you because it's cold at the moment, and I have no inkling to get into a pool. The idea of a pool, especially in a cold place like Kimberley, it sounds freezing cold. All right, but this guy Paul is in Kimberley. He wants to build a pool, which is fine. All right, he's in this municipality. He's planning to build himself a swimming pool, where the one part is obviously deeper than the other, which is the norm for swimming pools. The sketch of the drawing is given below, and the dimensions are marked on the figure. Okay, so we've got A, B, H, G, which are, if there's 4 letters, right, this is a core maths kind of thing, using letters to name shapes. All right, you don't often see this in math literacy. It's a core maths kind of thing. ABHG is got 4 letters, so that must be a quad. A, B, H, G. There it is there, that quad on the side. DCEF. DCEF is on this side of the pool. BCEH. BCEH is the base, the bottom of the pool. Those are all rectangles. They're telling us, yes, we can see they're rectangles. They're just telling us that those 3 quadrilaterals are rectangles. Okay. That's fine, but that's more of a core math thing. You usually don't see them name letters like that in the question. Yeah, Tando, I don't know about pools in the Free State, but I could be wrong. I'm a Durban boy, been here pretty much most of my life. So pools in the Free State, it could be a thing. I don't know. It sounds cold to me, especially in the winter. All right, here comes the first question. Calculate the area of ABCD. So when they say ABCD, that is a quadrilateral. And I'll highlight it for you. So A, B, C, D. So it's this front face here. It's this front face here. Now, who can tell me, do they know what kind of shape this is? This is not the primary shapes that we've been looking at, circle, square, triangle. What kind of shape is this this quadrilateral A, B, C, D? Can anyone tell me? Does anyone know? Anybody out there know what kind of shape this red shaded in region is? This quadrilateral here, A, B, C, D? Rectangle. It would be a rectangle, Tando, if this, so this side here, DC, is obviously the same as this side, 2,2. This would be 2,2. And the left-hand side, AB here is 4. So if those two were the same, it would be a rectangle. But because the one side is longer than this side here on the right, it's got to be something else. Irregular rectangle. Okay, it's a good description. Right angle, trapezium. There we go, Bianca. Trapezium. All right, it's a fancy name. You don't have to know that unless they told you in the question here is a trapezium, but it's a trapezium. It's like a rectangle, but one side's longer than the other. Okay. Also, these 2 sides here are parallel, but anyway, don't worry about that. You don't have to worry about that. It's just a trapezium. Okay, so one side is longer than the other. Okay, they want you to work out the area of this. They give you a formula like they always do. So Tando, let me quickly show you. So the question over here says DCEF. There we go. DCEF is a rectangle, which means that this one here is a rectangle. If that is a rectangle, that's why they tell us this in the question. If it is a rectangle, then this dimension here, 2,2 for F line FE, must be the same as this side here, 2,2 for DC. Okay, which means that FE and DC are the same because this is a rectangle. But on the other side of this quad over here, the line AB is 4 meters. So those 2 opposite sides are not the same. So if this 4 meters was 2,2, it would be a rectangle. But unfortunately, This side's longer, so it can't be a rectangle. So it's a little bit irregular, which is why someone said it's an irregular rectangle, because the one side's a little bit different to the other side. So it can't be a rectangle which has opposite sides equal. The one side's a little bit different. Okay, so they say work out the area of this strange shape. And if it was a rectangle, the formula would be for the rectangle would be length times breadth. So this strange formula they give us is for a strange shape. So all we need to do is take the formula they give us, the area of ABCD, this shape that's shaded in here in red, and sub in all the values that we need to and get the answer here. So AD, you need to put in AD. All right, the top is obviously a rectangle, so the AD must also be 13. We need AB, which is on the side here. And we need DC, which is on this side over here. Okay, so we're going to sub in those values and get an answer. All right, so it should take you guys about a minute to punch in those numbers. All right, you guys got an answer. Let's quickly do this one. So it is a half. I'm going to say, oh, let's use the whole fraction. So we're going to say a half, and we're going to times it by, and they've used brackets. It doesn't really matter if I don't use brackets here. So I'm just showing you guys, but I want the second part here to be in a bracket. I want that to be in a bracket. So 4 plus 2,2, that little addition sum there, I want that to be in a bracket. And we'll test to see, Lufuno's got an answer there. We'll test to see if these brackets make a difference. Okay, so they've recommended brackets around the 13. We don't really need it around the 13. And I'm checking to see. Yes, 40,3. Good job. Now, let's go back and take away these brackets here. I love using brackets, but let's see if with no brackets make a difference. Here. Oh, you see that? So if we take away the brackets, we get a different answer here. All right. So if we've got lots of different symbols in the expression, in the equation that you're trying to substitute into, be careful. Make sure that if they suggest using a bracket, put in that bracket. Okay. Does it matter if we change these multiplication signs to brackets? Let's check. It should give me the same answer. All right, yeah, there we go. So 40,3. So whether it's times here between these two or brackets doesn't make a difference. But when there's a plus here, which is different to the times, it does make a difference. Keep a bracket around that. Okay, so 40,3. And we are dealing with meters here. So I'm going to say 40,3 meters. Careful, it's area, so it's square meters. Yes, Tando, it does. So careful, you must use the bracket. Will they always give us a formula like that? They will, especially for a trapezium. They will give you formulas all the times for shapes. So you don't have to worry about them omitting a formula. I've got a question later on which kind of tests your knowledge, but they will give you formulas. The only hard part about them giving you a formula is what goes where. So when we did the surface area on Thursday last week, there are a lot. Yeah, they have to be, Anchor. There are a lot of variables. So what goes where becomes very important. But in these, for volume and area, it's pretty simple. It's just a triangular prism that can be tricky sometimes with surface area and volume, but you hardly ever see those. So it's not that difficult. It really isn't that difficult. You just got to sub in the right thing at the right place and be careful of brackets, round off when you need to, and you should be fine. Okay, here we go. Here's the next question. The swimming pool is to be filled with water. The formula to determine the volume is. Now, this formula is different to what we've seen before. Okay. We see here that in this formula, we need the area of ABCD. Okay. That comes from this question. All right. That comes from this question. Okay, so that's why we had to do this other question. Now, the numbering of the questions is very wrong. Don't look at the numbering, but that's why we had to do this question first. We need the area. Okay. And then we need to multiply it by AG, which is the length of a line. 2 letters means a line. All right, I'm going to move up. Don't worry. Don't worry about being late, guys. Remember also, if you miss any certain things, you can check the YouTube channel for the parts that you've missed. So I'm going to rewrite this formula. Okay, I'm going to write it right next to the diagram so you guys can see it. So the volume of the pool is the area of A, B, C, D. And you have to, let's move this down a bit so I can fit it in. I'll move this down to about here. And you have to multiply this by, I think they said AG. Yeah, AG. All right, that's the formula for the volume of this pool. It looks very different to what we used to. It does, because this is a trapezoidal prism. I mean, how's that for a mouthful? A trapezoidal prism. You don't have to know it. You don't get taught it. It's a strange shape. Don't worry, Ratabile. All right, so we got people already putting the values in. Okay, so the area is 40, comma, I think it was 40,8 meters squared or 40,3. Sorry, it's right there. 40,3 meters squared times AG. AG's got 2 letters, is a line length. Here it is there. All right, and we should get an answer from this. Yes, Bible, good. Mentioning that the units are cubed. Good. So 40,3. Let's check if you guys are on the money. Times 5 is 201,5. Very good. So it's 201,5 meters cubed. Okay. All right. I was going to take this answer and place it down where it's supposed to be. All right. Very good. Yes, we just took the previous answer and multiplied by 5. The previous answer from the previous question multiplied by 5. Yes. Good. So I'm going to paste that one there next to that question. And they want us to work it out in cubic meters, which we've just done. And they want us to work it out in kiloliters, where 1 cubic meter is 1 kiloliter. I mean, sure, guys. It's a 1-to-1. We've got cubic meters already, 201,5 cubic meters. They're telling us every 1 cubic meter is 1 kiloliter. It's a 1-to-1. All right. I'm going to say C for capacity is equal to 201,5. I'm sure you're all screaming at the screen like, come on, sir. What is this? Complex questions. I might just check. I'll go back up. Oh, there's a calculation over here. All right, so here's the calculation for the volume in cubic meters. And this value here comes from the previous question, the first question. All right, so just check what you've written down there, what's on your calculator. Okay, yep, it's a straight 1-to-1 conversion, ladies and gentlemen. So you should get 201,5 kiloliters. Come on, where's the complex stuff? Well, this is just a warm-up, eh? We're just warming up here. We're just warming up. All right, you all are very quiet and I haven't heard one voice. Is it too cold to talk? Even Kia's quiet. It's too cold, guys.
It's very cold.
Ooh, it's too cold. All right, yes, question. They call it question number 6. The Salt Lake municipality charges 6.65 per kiloliter. Calculate the cost of water needed to fill the pool. Nice and easy. Calculate the cost of the water needed to fill this pool. If it's 6 Rand 65 per kiloliter. Should take you a minute, guys. Should go nice and quick. Who's out there that can help me do this one? Anyone got an idea? Raise your hand, unmute quickly, tell us, what do we do? Help us out here. Help us out letting the people know. Sure.
You're gonna start with Lufuno. Just make sure
Oh, okay,
that
sorry.
you
I pushed the wrong button then. Sorry, Kia.
no problem. Hi
Lufuno, hi.
Lufuno.
Hi, how are you guys?
Good, and you?
Yeah, I'm good. I'm good.
Is it cold
Just
there?
cold. Too cold. Yo,
Where you
yo.
from, Lufuno?
I'm basically from Eastern Cape, but I'm currently living in Witbank, in Mpumalanga.
It must be cold.
It's very cold. I even forgot my jacket today. Ish.
Sorry, man. All right, Lufuno, please help us out. What do we do here?
Okay, so I have like a different method. I'm not sure if like in other schools they use it though. So what I do is I wrote it down. 1 kiloliter is equal to 6.65.
Yeah.
Then I took the 201.5 and put it on the 1 kiloliter side.
Yep.
Then on the other side, I put a question mark. So therefore, 201.5 divided by 1 kiloliter times 6.65 gives you 1,339.98.
Absolutely. All right. So this is a very good way to work with numbers that have relationships. So we can see that there's a relationship here. Stay on the line with me. Well, stay on the line like it's on a telephone line. Stay with me. There's a relationship here. 1 kiloliter equals 6.65 Rand. So that's the relationship. Okay. So when you have numbers that are in relationship like this, like it's boyfriend and girlfriend, they're married or something in relationship. If there is a relationship between a pair of numbers like this, then what we can do is you can say to yourself, if we've got a same units, a new value with the same units, we can ask ourselves, what did we do to this 1 kiloliter that it became 201.5 kiloliters? So Lufuno is suggesting to find that out, you can divide the two numbers. All right. So 1 times something equals 201.5. So what he's saying is divide the 201.5 by the 1 to get this value. Okay. And then use that to times your 6.65 Rand by. So you're going to times 6.65 Rand by this number because you're timesing the 1 by this number to get 201.5. Absolutely. Absolutely. I often use this as well when there's a relationship between two numbers. All right. So, Lufuno, thank you for that, man. It's a very good method. Do you use it often?
Yeah, I use it every time, even when I do what's this, measurements and stuff like that. Yeah,
Conversions,
conversions.
exchange rates.
Same.
Yeah.
Yeah.
Yeah. Yes. Okay. So I also do the same thing. I say, ask myself, what do I do to this one
What do I do to this one
to make it become
Hello.
201?
to make it
Hello?
become 201? Hello?
Sorry, sir. For interrupting. I'm very confused. I thought we were supposed to use the conversion method for this question, like cross
Okay.
multiplication.
Okay.
So you
So
see,
like when
Do you see?
yeah, I'm listening.
because I wasn't like here earlier on, so that's why I'm confused.
Oh, okay. So we've gone through a
Okay.
series of
So
questions
we've gone
here.
through a series of questions.
Before Karen, just turn your speaker down. Your speaker. Oh, there we go. All right. So I've gone through a series of questions here to get to this point. We're talking about a pool, and we've gone through a series of questions here. Number one, what's the area of this red shaded shape? We then use that to work out the volume of the pool in cubic meters. Then they wanted the volume of the pool in kiloliters. And this is where they gave us a volume to capacity conversion, but it's 1-to-1. So we don't really have to do much. So we take our volume and change it straight into kiloliters to capacity. And then they say, if this is the capacity in fact, a lot of times when there are questions that follow on like this, it's called scaffolding, they will often use the word hence at the beginning of this question, this next question here, question 6. Hence, if you have these numbers, use them now in this question. That's what that word hence means. If you've got an answer here, use it now in this following question. They say, the municipality charges R6.65 per kiloliter. So if for every kiloliter we have in here, it's R6.65. So we're just setting up, Lufuno's just setting up a relationship here. He's saying, sir, I know 1 kiloliter is R6.65. I need to know how much is 201.5 kiloliters though. So he's setting up this relationship and saying, I need to times the 1 by, and it's 201.5 to get 201.5. So I must times this by also 201.5. Okay, so we're not using conversions in this question. We're just using the idea of a relationship between two numbers to try and work out what is this missing value here. Okay, does that make sense? I hope that makes sense. I hope we caught up. Now, if you come in a little bit late, it does get confusing. So now we just have to multiply. So I'm going to say R6.65 times 201.5. 201.5 times 6.65. And like everyone is putting into chat there, 1339.975. I'll write that out. 1339.975, but I'm rounding off to 2 decimal places wherever I can. So that's 1339.98. I hope you guys all got that. All right. I hope you all got that. Rounding off. Yes. Okay, good. Some people rounding, some people not rounding. This raises a very good point. Now, I'm not sure, and Kia can confirm as well, the policy for marking rounding. So you see 2 answers here. One is rounded and one is not rounded. There is an instruction at the front of the exam that says, give your answer to 2 decimal places unless told otherwise. Now, if you do not round, they're going to penalize you somewhere. I don't know if they'll penalize you everywhere. If you did 50 times in the exam, I don't know if they'll penalize you 50 times, but they will eventually catch you. So save the hassle. Don't give them an opportunity to mark you down on anything. Always round off to 2 decimal places unless the question is specific. Make it a habit. No, we don't round up. The only time we round up is if we're doing a job and we need materials for the job and you don't have enough, then round up. Okay, that's when we round up. That's the only scenario. Okay, so always round off to 2 decimal places. Make it a habit for everything you do, but only at the end of the question. Okay, don't do it in the question. Keep your accuracy. I know if you see lots of decimals, your normal reaction is, chop it off, round it off. Don't do that. Only round off at the end of a question. Please, 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 please. All right. Okay, here we go. Here's the next question. What is the depth at the center of the pool? I mean, come on. What is the depth at the center of the pool? You may use the formula. You may use the formula. We're going to use that formula because we're not like engineers. We're going to use your formula. The depth at the center of the pool. So if you were in the center of the pool and you went down, 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 right there at the bottom on the floor of the pool, what is that depth? I don't know. We could sit, we could work it out, or if we sit here all day and try to work it out, but let's use the formula. All right, so D for depth equals a half, and I'm going to write this out first, and then I'm going to stick it up there by the diagram because I know you're all shouting at me saying, Dale, we can't see the diagram. All right, well, let me just take this formula and I will stick it up here next to the diagram, and then you guys can do it. That's not the right place. There we go. There's the formula. I'll move it down slightly. There we go. There's the diagram. Now you can do it. Yo, you guys are fast. Are you telling me that when I looked up to draw the center of the pool, you guys already were starting to put and subbing the numbers in. Yo. All right, looks like you guys are ready for the good stuff. You know, this is too easy.
You need to display those kinds of questions that make people put emojis on the chat.
I think it's time for those. I do think it's time for those. All right. Okay.
Or
I
a
thought it was,
break first.
yeah, we'll do a break. We'll do a break and then we'll deal with those. I thought it was being generous, yeah, but I get the feeling that people were like, come on, let's go, let's go, let's go. All right, all right, all right. I get the message. I get the message. 3.1. It's just 3.1 meters. Not meters squared or meters cubed. It's a length. Some people are disagreeing with Kia and say, no, Kia, we don't have to do that. We're very happy with this level. Very, 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 very happy with this level of question. All right. Okay, a little break before we carry on. I know guys like Ben are keen to move. Let's have a little break. Does anyone know what the temperature is going to be tonight? Minimum temperature? Minimum temperatures in your region. I'm from Durban. Where are you guys from? Put it in chats. Type in there, Oudtshoorn, -16. Karoo, -25. Put it in chat there so we can see where you guys are from and how cold it is. Free State, Tando, how cold is it there? Safiso wants to tell us personally how cold it is. Safiso, you there?
Yes, good day. How are you?
I'm good. How are you? Is it cold there?
It's very cold, sir.
It's crazy. Oh,
But
I feel like
but
this
now,
winter.
sir,
Yeah.
excuse me, I'm having problems with trying to do the quiz because it's giving me problems. It says unable to reach link or something like that. And I tried texting the WhatsApp number. They gave me the link again, but I can't do the quiz.
So when you click on the link, what does it say?
It says unable to connect with link or something like that.
Okay, there's two things that I think would cause it. Number one, an internet issue, but I don't think that's your problem. So if you're not connected to the internet when you do it. The second thing could be a user problem. In other words, if you're not logged in, because I think the link records your username. So maybe go via the website if you can log in there to get the link.
Yes, I did the
And then
same thing because on WhatsApp they gave me the link to join via the website and the app, but it kept on saying unable to connect with the
all right.
link or something like that.
Okay, so Fiza, what's going to happen is Kia will record your name, and she will send your name to the people that deal with this kind of thing, and then they'll come back to us. And then on Thursday, when we see you again, before we give you the quiz link, we'll let you know what to do, or they'll contact you between now and then. Okay.
Okay, no problem, sir.
Awesome. All right. So Kia will
Thank
take
you
your
so
details,
much.
and then we'll get back to you. Okay.
Okay, thank you.
Awesome. Just having a quick look at these temperatures here. Jersey, PMB 11. PMB is near me, 11. 7. 1. Yeah, Centurions 1.
This one is
Believe that.
lying.
This one is like, someone's like saying this one is like,
one.
guys, 1. That's 1 degree away from turning into us. -3 Midrand. Lesejo. -3 in the
I'm
Midrand.
seeing a
Honestly,
68 degree
13
to
degrees.
55 degree in Free State. Is Free State in South Africa or not? It's so cold everywhere else except the Free State,
Oh.
clearly.
So at 68 degrees, that's Fahrenheit. That must be Fahrenheit. Yeah, I see Tando's practicing his conversion between degrees Celsius and Fahrenheit. That's what that is.
I can
Can I
only
ask-
hope. Otherwise, I'm going to Free State now.
68. Jeez, the skin will fry off us. Oh my gosh. Yo, there's some cold places tonight, guys. Please stay warm. Hot beverages after this lesson. All right, Rusks, no Mori biscuits. Okay, you know how we do in this class. 12. Lefuno's correcting there. 12 degrees, but back. Okay, good. 1 -1, guys. Oh, Lesejo, please stay warm. All right, Please, please, please get some tea after this lesson. Stay warm, guys. Stay warm. Yeah, Free State, Bianca. We're going to the Free State. Get your costume. We're going to build a pool in the Free State. Never mind Kimberley. We're building a pool there. We're swimming there now, today. Gauteng, 5 degrees Soweto. Yo, 14 Pretoria. That's not far away. It's a Pretoria and Soweto, not that far away, and it's a huge difference, guys. It's cold. Please stay warm. Hot beverages after this lesson. I got something else that'll heat you up. I got something else that'll keep you warm. Just next question. I'm going to see red faces in this next question. Guys are going to get warm now. All right, this will help you. I'm helping you out here. Free State is no joke. It's very cold there. Burgersfort. Where's Burgersfort, Mohammed? Burgersfort. Okay, here's the question. While Mohammed's telling us where Burgersfort is, the diagram below shows a rectangular prism-shaped water trough made of concrete. Okay, so this trough is a trough that animals drink out of, obviously, and it's made of concrete. Okay, it's rectangular. You obviously pour water in here to give water to your animals on your farm. All right, so that's what it's a drinking trough, and it's made of concrete. There are dimensions for it. We've got length 3 meters, width 683 millimeters, height 40 centimeters. I don't know if you can notice something there. I don't know if you noticed something there, ladies and gentlemen. Whoa. Crumbs. Yes, Kazimla, exactly. 3 different units. Which one must we do? There's not even a hint. Usually there's like 2 out of the 3. We get an idea of where they're going. But there's 3 different ones. Oh my gosh. Yes. Readability, the units are not the same. Loading, yeah. Question 1. Calculate in, thank goodness, centimeters cubed. The volume of concrete used to make the water trough if the trough can hold a maximum of 485 liters. Now, do not be blinded by the simplicity of this question or how simple it looks. There's a lot in here. Okay. Calculate in centimeters cubed the volume. So we need volume. You know the formula for that, right? The concrete. Okay. There's no concrete inside here. They're talking about this layer of concrete. That's what they're talking about. All right. Okay. They're talking about the width is, it looks a lot bigger, but there's we've got millimeters here for width and 40 centimeters there for height. So if you convert the width to centimeters, excuse me, I won't look at that different. Careful, guys. They want the volume of concrete. So you see that the boundary, this gray, the thickness of concrete that makes up this trough, not the inside, the boundary that makes this trough. They want to know its volume. Kagiso, no ways. Yo, Kagiso, I don't know, man. I think the speed is incredible, but I don't know if the quality is good. Who can come online and tell me what on earth we do here? We're gonna have to, Tana, we're gonna have to convert somewhere. Kagiso, tell me how you doing this and it happens so fast. Tell me what you're doing,
Yeah.
Kagiso.
Well, I'm almost done. Okay, let me start. So we have to convert the meters and the millimeters. So you have to say 3 times 100, which is going to give you 300.
Centimeters, yeah. All right, hold on. Let me do what you're saying. Yes, so 3 meters times 100. Convert everything first to get centimeters. So that's 300 centimeters. All right, with you, what's next? Kagiso, check your screen there. There's a little option to unmute. Oh.
Unmute. Okay. 685 millimeters divided by 100.
Divided by
100.
oh, careful. From millimeters to centimeters, you must just divide by 10. There's 10 millimeters in 1 centimeter. So you must just divide
Oh
by
my
10
God.
there.
Sorry, it's 10.
Yeah, so it's 68,
It's going to give you 6,8.
yeah, okay, 68,5. And then the height we keep as
6,5.
yeah, 68,5, and the height we'll keep as 40. So right, so Kagiso is changing everything to centimeters first. Good. What do I do now?
Yeah. You multiply all of them and it's going to give you 822,000. 100,000, yes.
All right. I heard you changing your 60.
And then after,
Yeah, I'm listening.
okay, and then after getting your answer, which is 822,000, you're going to go back to the 1 liter is equals to 1,000 centimeter
Yeah,
cube. We're
yeah.
going to do a cross multiplications. Like terms go together, where we're going to cross multiply
All right, let me just write it out. So 1 liter is equal to
is equal to
1,000
1,000 centimeter
centimeters
cube.
cubed. Yeah.
One times 822,000 divided
Okay, hold on. I'll be with you
by
now.
1,000.
Yeah, I'll just write it out here. So we need to have 82000 over here. Okay. And we're trying to work out what is this number over here. Yes, I'm with you.
I think I made a mistake. Oh no, I'm incorrect. You know what we have to do? Since we're using 485 liters water, we have to use the 485 liters instead of the 822,000
Okay.
because we have to get 485,000 in order to subtract the centimeter cube.
Yeah, so this
So
is
we
a
have to
question
use
mark. And over here,
485 liters.
485. Yes.
liters.
Okay, good.
So instead, we're going to say 485 times 1,000.
Yeah.
Which is going to give us 485,000. Okay, yeah.
And this is centimeters cubed, hey?
Yes. So after this, we're going to say 822,000 minus 485,000.
Okay, you got to tell me why we must minus that, because there's people listening that are like, why is she minusing these two numbers? We've got these two numbers, but why are we minusing? Just explain to us.
We're looking for the liters of water, so they all contribute. I don't know if it's a correct answer, but that's how I know.
You're on the right track. You're on the right track. So
Really?
we got two values here. So let me try and help the guys that are listening understand. So this 822 here, we worked out the volume of a rectangular prism, which assumes that this whole trough is filled with concrete. Okay, just hold on now. I know what you're thinking, but sir, it's not filled with concrete. Yeah, I know. But we are pretending that we have a rectangular prism or block that is filled with concrete, and we multiplied out all the centimeters. We had to convert some first, multiply them out to get a centimeter cubed volume for a rectangular block of concrete. Okay, now what we're doing is we're hearing that this block is actually filled not with concrete, but with water. So you're taking some of the concrete out and replacing it with a volume of water or capacity of water. Okay, they give us that water in the capacity form, which is here in the question. They say it's 485 liters of water. So it's not a solid concrete block. There's a gap there, and you can fill it with water, exactly 485 liters of water. Now, what we need to do is work out what is the difference between the outside of this trough and the inside, which is water. The outside is concrete and the inside is water. So what we do is we take
We have
this,
to subtract the
we have to
inside and the
subtract, yeah.
outside.
So we take this value, which is 822,000, which is as if it was all filled with concrete. We subtract the 485,000, which is the part that's inside that is water.
And it's going to give us 337,000.
Yes, and that'll leave us with the outer boundary, which is just the concrete. Okay. So we subtract these two, and we should get, so 822 minus 485,
337,000.
337,000 cubic
Centimeters,
of concrete.
yes.
Yeah, of concrete. Okay. Does this make sense, guys? And it's an important question. Very well done. So that's brilliant. I was shocked. I was like, no. That's too fast. Well done. I'm impressed. You've impressed me. Thank you very much. So it's an important concept to understand. You've got a shape we've got a volume within a volume. All right. I hope you guys can understand this. If not, please speak. So what's happening here is we're pretending, and I'll use gray here to try and make sense. We're pretending that this whole trough is filled with concrete, first of all. So I'm coloring it in. I'm filling it with concrete there on my screen, okay? So we're filling in the trough with concrete to make it one big solid concrete block. Okay, that's the first thing we're doing. That concrete solid block has dimensions, okay? Its length is I'm going to use centimeters now. Its length is 300 centimeters. Its width is 68.5 centimeters. And its height is 40 centimeters. Now, if I asked you, determine the volume of this. If I asked you to determine the volume of this concrete block, you would all go to this formula. You'd pull out the volume formula. Volume is equal to length times breadth times height. You'd sub in all the centimeter values, and you would give me an answer of 822,000 centimeters cubed. That is the volume of this rectangular prism, this concrete block. Okay. You would all be able to do that. The hard thing first before that is, number one, you've got to convert everything to centimeters, but they tell us that we have to work in centimeters so that you would know to do that. And then subbing into this formula. Now, you wouldn't know why you're doing this. Let me explain. So you're working out the full concrete block first, and then you're going to take out some of the middle of this block, because they're saying it's a trough, right? So there's a space in there, in this trough, which is hollow, that you pour water into. All right. So it's not a big solid piece. It's a hollow piece. Is a section of volume or capacity that's been removed. Okay, we're going to work out what that is just now. But they're telling us that it holds a capacity of water. And now you can see there's a space there in this trough. And we're filling that space to the top with water. Okay. We're filling it with water, so I'm drawing in blue now to show you that this trough has a void or a space in it that can be filled with water. The outside of the trough is still concrete. There's concrete all along the edges, which is why I pointed to it with this black arrow here. I said, guys, they want us to work out the volume of the concrete only. Okay, so what do? Well, we pretend it's solid. Then we remove the water, which should be filled with water. We remove that water part, and you're left with the concrete on the outside. Okay, so you take a solid thing, you remove a piece in the middle, a cavity in the middle, a volume in the middle, and you're left with the outside. That's what you're doing here. Okay, so that's why Kagiso said we should subtract. Take the volume of the whole prism as if it was whole and filled with concrete, remove the water that it can hold, and this is what you have left. So if I draw over here and write words, I'll use words here and I'll use red so you guys can see it. Okay, so I'll use here, this is the concrete, a whole concrete prism, a whole one. Okay, and this here is the water inside. All right, so if you had a whole concrete block, and then you had some water inside that you removed, a space inside that you removed, you left with the outside concrete. Okay, that's what the question is asking for. I hope yes or fancy. I know. Do you know what other famous example they do with this kind of question? Is they do one with cakes. I don't know if you've seen it. All right. So this is a top view of a cake. They'll say this person made a cake, and inside the middle of the cake is a hole. All right. So this here is all solid cake or a donut. Let's pretend it's a cake, then let's not say donut. This is a cake. We're looking at it from the top. Okay. They say the cake has a height, it has a diameter, whatever. You can work on its volume. They want to know what is the volume of the cake. All right, that is over here. Now, if we didn't have a hole, it's a much easier calculation. All right. But because there's a hole here, you've got to do something. You've got to take a normal cake, which is the same thing. All right. You take a cake that was whole, like this one, work out its volume, and then you work out the volume of the hole inside. And you remove the hole. And then you left with the remaining cake. All right. I think you guys might have seen that kind of question. So you have a whole object with a whole volume, no holes in it, nothing, no void, no spaces in it. You remove the hole and you left with what's on the outside. It's a similar question to the cake question. Okay. So that's what they're asking here. They don't want a whole concrete block. They want the outer part of the concrete block. So there's a rectangular prism in the middle, which is a volume of water, and there's a bigger one on the outside. You must remove the two. Okay. All right. So sometimes they'll actually give you dimensions for the inside of the trough, dimensions for the outside, dimensions for the inside, and they'll say, what is the volume of concrete? Then you work out the rectangular prism on the inside, you work out the rectangular prism as a whole, and you subtract them. Okay, but this, in this case, they gave us the volume. Yeah, they can show you different kind of case as well. They gave us the volume in capacity form. So they'd already worked out the volume. They gave it to us in capacity form, 485, and a conversion, so we could change it to volume, which is centimeters cubed. Yo, it's a lot. It's 7 marks. This is the one that needs to, if you want to be the person getting 85% or 90s, then you've got to wrestle with this question. Okay, you've got to be able to wrestle with this. And that doesn't mean that you're not going to get 85 or 90s, but there are a few of these in every exam, and you need to be able to wrestle with these. Okay. All right, last one for the night, and I can see that you guys have had enough now. Like, all right, after that, I'm walking away, I'm going. But here we go, it gets a little bit easier. Okay, here's question 2. A cow drinks 56 liters of water per day. Zippo states that a full trough has enough water for 8 for 1 day. Verify with calculations if this statement is correct. So we got one cow, 56 liters of water per day. He says the water in this trough is enough for 8 cows, and that was 485 liters. I'll write it there. The water in this trough, which is 485 liters, is enough for 8 cows in 1 day. So I'm all squeaming. I give you 9 months and you're going to be answering questions like this. Promise you. You stick with the program, you keep working at it, and you're going to be answering questions like this. Yo, Kagiso with the speed again. All right, we're going to give you guys some time to do this one. Remember, they're asking, is the statement correct? Is the statement correct? He says that this trough will supply 8 cows per day. Is the statement correct? You should say, yes, the statement's correct, and then back it up with some calculations. All right. So remember in the exam that you're going to say, yes, the statement is correct, or no, the statement is not correct, and then back it up with some calculations. All right. All right, we got some answers coming through here. All right, while I'm doing this one, those people that are finished can look at number 3. All right, so let's check. So if we have 56, one cow does 56 liters in a day, and he has 8 cows, we'll multiply that by 8. That's a little bit easier. Whew, not so bad. 448 liters. So 8 cows can do 448 liters in a day. Now, all you people that are saying he's not correct, careful the question. Look here. It says, Zemo states that a full trough has enough water. Well, it does, because a full trough has 485 liters. His 8 cows only need 448 liters. So yes, the trough has enough water for his 8 cows for one day. So the statement is correct. All right. So statement is correct. All right. It's enough. Okay. Yeah, it's okay. You knew the calculation and you jumped to the calculation. Be careful. The question says has enough water. Does it have enough? If the question was, is the exact amount, then it wouldn't be correct, but it has enough. Okay. Question 3. Determine how long to the nearest minute it will take to fill a half full trough if the water flows in at a rate of 14.5 liters per minute. Determine how many minutes to the nearest minute it will take a half full trough if the water comes in at 14.5 liters per minute. All right, I'll give you a couple of minutes to try this one. How long to the nearest minute for a half full trough if you're filling at 14.5 liters per minute? How much do you need a calculation? All right, so this calculation that we have here is backing up our answer. So you could add this, you could say the same is correct as 8 cows, or you could say, sorry, statement is correct as trough has more than enough. All right, the question says that the trough is 485, our 8 cows need 448, so the statement is correct. You will have enough as the trough is more than enough, okay. But you need a calculation to back up your answer. It's not really what you write in the sentence. It's correct or incorrect. Back it up with a calculation. All right. Question 3. How long to fill half a trough if it's 14.5 liters per minute? Under the 45, where are you getting the 45 from? First thing we need to do is work out what is half a trough. A full trough is 485, so what is half a trough? All right, Dana, no worries. Ben's got an answer there. He says 33 minutes. Round it off to the nearest minute. All right, one more minute, and then we're going to check this one out. In the meantime, I'm going to work out what half a trough is, because the question is talking about half a trough, which means we must divide that by 2. That's 224 liters. And they're saying if half a trough fills at 14.5 liters per minute, how many minutes will it take? Ooh, we've got all kinds of different answers here. I love it. I love it when we get different answers. All right, one more minute, guys, and then we're going to try to do this. So if, on the screen, you can see I've already worked out what half a trough is. All right. And also just don't forget to round off to the nearest whole minute. Right, round to the nearest minute. Round to the nearest minute. Okay, we've got answers coming up all over the screen there. We've got different answers. I love it. Ben's changing his to 15 quickly. That's fine, Ben. Not a problem. All right, we're going to wrap up the lesson now by going over this last one. The Sofu has already got an answer there. So we got 224 liters to fill. We're filling this at 14,5 liters per minute. So I want to know how many 14,5s do I have in here? All right. How many 14,5s do I have in here? You guys, like has been suggested tonight, will use a relationship like this. 14,5 liters is equal to 1 minute. Then how many minutes is 224? So you guys will use this kind of relationship. Absolutely fine. All right, so let's use this. So what I would say is, what do I need to do to 225 on the left to get it to 14,5? Okay, so we could divide those two. Okay, so we could say 224 liters divided by 14,5. All right, that's going to give me this magic number that I need to multiply by to get to 14,5. All right, and then I'm going to, oh, Cajisos raised a hand there.
Sir,
Tell me.
when I punch my calculator saying 485 divided by 2, it gives me 242,5.
I must have made a mistake. Maybe I've got the 448 instead of the 485. Let me check. Yeah, I had the 448, my bad. Let's see. Yeah, I had the 448. Sorry. So it's 485. Thank you, Giso. 485 divided by 2. All right, a correction there. So 242,5. 242,5. 242,5. 242,5. 242,5. 1242,5. Yeah. All right. There we go. Thank you, Kajiso. We corrected that. I was using the wrong 400. Okay. There we go. So 242,5 divided by 14,5. I'm going to actually get this number and show it to you. You don't have to. You can go straight into the next step, but let's see what it looks like. This looks like 6. Oh, that's horrible. I'm not going to show that. Okay, so let's not even write that down. So there's a magic number that you need that sits over here that the calculator is showing you. If you want to write it down, you can. But all we know is that magic number is what you must multiply this by to get 14,5. You say 242. Sorry, you're dividing. You say 242 divide by that magic number, and you'll get 14,5. Okay, so we need to work backwards now. Okay, so we're going to work backwards with the same number now. All right, that magic number. No, we don't need to. We don't need to multiply. That is the answer, isn't it? It's 16,7. Yeah, we're done, guys. We're done. We just need to round that horrible thing off. All right, let me write that horrible thing down. So 16,7241, 7241, blah, blah, blah. And this is minutes. Yes, Mohammed, I see that hand. Hold on. So we round this off now to the nearest whole minute. There we go. We're done. Yes, we're done.
Sir,
Mohammed, yes.
now 16,72. 72 is not a minute. So how do I get that to minutes? 7241.
So you're saying, how do we go from 16,72 to 17?
Yeah, how do I get 0.72? Like, how do I get it to minutes?
We don't need to. So they're not asking for this. Okay, I see what you're saying. They're not asking for the answer in minutes and seconds. They're not asking for the answer in that format. They're saying whatever you get here is your decimal over here. Quickly round that up to the nearest minute. Okay, so we don't need to go to minutes and seconds unless the question wants us to. We just need to take our decimal minutes here and round up 2 minutes straight away. So if it's 16,7, go to the nearest minute, which is 17 minutes. But I hear what you're saying. What you're asking is, how do we convert decimals into minutes and seconds? Well, you'd say this. I'll quickly show you. While Kia puts the poll up, it's 16 minutes and comma 7241 blah 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 divide, sorry, not divide, times by 60. All right, times by 60. It's 0.7241 of 60. Now, hold on, let me just quickly show it to you. All right. That's not what the question is asking, but if a question does ask for minutes and seconds, then you would do that. Okay, let me just quickly show you. So minus 16. There's our decimal. Times it by 60. So it's 43 seconds. All right, so if the question asked for minutes and seconds, you would take the decimal portion, 0.7241, blah, 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 and times it by 60, because there's 60 seconds in a minute. All right, but this question doesn't need that. You got it, Mohammed?
Thank you, sir.